Welcome to Edivon. For over 30 years, we have provided premier technical teaching equipment across the globe. Our product range covers most technical areas, which include engineering physics, electronics, communication, and renewable energy. Every Edivon product is designed, manufactured, and quality controlled at our headquarters in Madrid, Spain, under several quality standards. In this video, we're going to be discussing Edivon TVAR22C series computer control, heat pump, air conditioner, refrigeration unit with cycle inversion valve. The TVAR22C is a computer control unit designed to study heat pump's performance and also the changes in the refrigerator condition, just like water and air, allowing the study of the coolant circuit. The heat pump, the cooling or air conditioning equipment are basically created of that cooling circuit. This unit has a water condenser and an air evaporator installed to either allow water warming and or air cooling. If both of them are selected for a particular task, water warming and air cooling will occur. The more detailed the equipment is, the more cooling or heating possibilities will include. For example, if two condensers are included, one of air and the other with water, there will be the possibility to warm water as well as air. Finally, if the equipment with a cycle reversing valve is selected, it will allow interchanging the condenser or the condensers by evaporators and vice versa. This unit is supplied with a SCADA computer control system, which is patented by Edivon and based on LabVIEW. The system includes the physical unit, the control interface box, a National Instrument Data Acquisition Board, and a software package that allows computer control, data acquisition, and data management. TVAR22 series equipment. As you can see, the equipment has a TVAR22C unit, a PLC module control, and a TH series computer control. TVAR22C unit. TVAR22C unit main components. Number 1, compressor. Number 2, condenser. Number 3, expansion valve. There is a top view of the unit for a better visualization. Unit main components in detail. Compressor. The compressor is a device used to increase the steam pressure until it reaches the compressor's pressure. This pressure increment increases the temperature at its outlet. Condenser. The condenser is a device where heat is transferred to the hot point. In here, there is a change of state from steam to liquid due to the fluid condensation. This process decreases or increases the temperature. Expansion valve. The expansion valve is a device that decreases the pressure until the working fluid becomes steam pressure, keeping the enthalpy constant. Installation outlet used in air conditioner and heat pump. Here is shown how all the components work together. TH series computer control, also called control interface box. This box is connected to the computer, the unit, and the PLC module. Temperature pins are shown, going from ST-1 to ST-10. A refrigerant flow pin is shown, called SC-1, and two water flow pins called SC-2 and SC-3. Two pressure pins are shown, called SP-1 and SP-2. Now I'm going to perform a practical exercise for this equipment. First, you have to make sure the water valve is open. Second, you have to make sure all the valves for air and refrigerant are open too. There are 4 valves. This is an evaporator and a condenser, and the one on this side is an evaporator and a condenser as well. You can invert both cycles with this inversion valve. Now, after you open all the valves, you have to choose the position of the equipment. It can be position 1 or position 2, depending on the process you want to perform with this equipment. We are going to choose position 1. and then choose the speed of the fans. Use 50 for both fans. Click Start, and then you will hear how the equipment starts working. It's very important to know that once you choose position 1 and press the compressor button, you won't be able to change from position 1 to 2. Now you can press the compressor button. You will hear how the compressor starts working. Now let the equipment to stabilize. You can see on the screen how the numbers start to change on the right top side. Once all the numbers on your screen are stabilized, you are going to choose the parameters you want in your graph or graphs. You can select graph A, graph B, or both. Once you choose the parameters for the plotting data, click Save Data. Select how you desire to save your data, click Stop, and then View Data. This way you'll be finalizing your practice. Now I'm going to show you how the software works. Before we start the experiment, I will explain the layout of the user interface. The main controls are in the upper left corner. These include Calibrate, Start, Stop, View Data, Quit buttons. A schematic diagram shows the layout of the components in the system right in the middle of the screen. Sensors are located in the upper right corner, showing all the temperature, water flow, and pressure pins. The actuators are located in the middle right of the screen. Here is where you start the compressor and choose between position 1 and 2. It is very important to know that once you start the compressor, you can change from position 1 to 2 or vice versa. Fan controllers are located at the bottom right. Here's where you control fan speed up to 100%. The interface can display two independent graphs or one large graph using the drop-down selection. The parameters that are displayed on the graph can be selected on the bottom left region. Okay, let's begin. In this experiment, we will do the preparation of the performance curves of the heat pump based on the properties of the refrigerant and at different condensation and evaporation temperatures. Air has a heat source, water-air heat pump. First, make sure the water and air valves are open and to turn on the water in order to perform this practical exercise. Click Start. A file dialog screen will appear and it will ask you where you want to save your data files and to name it as well. Once you're done, click OK. As you can see, position 2 is selected and the cycle arrow is red, going in the clockwise direction. For this practical exercise, we will choose position 1, and by doing this you can notice how the cycle arrow changes to green and then to counterclockwise direction. Next, choose the desired fan speed. We are going to use 50 for both fans. You can just simply write the number 50 in the boxes. Then go to the left part of the screen and choose ST9, ST10, SP1 and SP2 for graph A. This will be a temperature versus time representation. Notice how lines show up in the graph. Using the drop-down arrow, choose graph B and select SC2 and SC3. This will be the pressure versus time representation. Using the drop-down arrow again, select group A and change the scale from 100 to 30 and from -5 to 0, simply by clicking on 100 and writing 30 for a better visualization of the graph. Do the same thing for graph B. It's very important to note that once you click the compressor button, you won't be able to change from position 1 to 2 or vice versa. Click on the compressor button and notice how the light turns green. Let the system to stabilize for a couple of minutes and then click the Save Data button. Notice the yellow notification at the right side of the screen, explaining why you can't change from position 1 to 2. The data is being saved now, shown by the Saving Data button. You can choose how to save your data. Notice that it says 1 seconds, meaning that every 1 seconds data will be saved. You can write the number you prefer or take data manually by clicking on the Take Data button. Once you're done taking the desired data, click Stop. To review data, click on the View Data button. A new small window will appear, showing which document or data the software will open. Just click OK. The data graph will open, showing the selected parameters with a check mark. You have the option of changing the colors of the selected parameters. I will change the color of ST3 from yellow to a red color. Then, click the Autoscale button to a better visualization of the data. To close the graph, click Close button. Recommended accessories. For refilling R34A refrigerant in maintenance, we recommend T/KI-T1 maintenance kit containing vacuum pumps, hoses, and manometers. T/KI-T2 maintenance kit containing leakage detector. R134A refrigerant to be acquired by the customer locally. The user manual provides multiple practical exercises that walk the student through the correct operational procedure while teaching specific concepts. Here is a diagram of the general TH series, followed by a T-bar22C series diagram. These are examples of the logos stick to the front and back of every unit we produce. Only Edivon has a SCADA system that provides the following benefits: open control, multi-control, and real-time control. This means that at any time during the experiment, multiple parameters can be changed at the same time with instantaneous effect on the unit. Each unit has specialized Edivon control software based on LabVIEW to enable AC control of the unit. Calibration exercises which are included teaches the user how to calibrate a sensor and the importance of checking the accuracy of the sensors before taking measurements. Projector and electronic whiteboard compatibility allows a unit to be explained and demonstrated to an entire class at one time. The system is capable of being remotely controlled over the internet by the user or by an Edivon technical support engineer. Each unit has 4 safety systems that are designed to mitigate risks for the user. This unit has been designed for future expansion, such as incorporate in the unit an Edivon SCADA-NET system, which enables many students to simultaneously operate any unit in their SCADA network. The following is included with every Edivon unit: 8 manuals including a user manual that explains the scientific theory being studied, any related mathematical equations, the function of each component in the unit, and how the unit is operated. Each unit is designed and manufactured under strict quality control, which allows to offer a 3-year guarantee against any manufacturing defect and components controlled during the lifetime of the unit. Lastly, due to the previous cited points, Edivon proudly provides full customer satisfaction. Thank you for watching this video. A link to our website can be found in the video description below. For more information, please contact us by phone or email. We look forward to talking with you.